Thank you for joining us as we take a look at how to handle data in business rules. To start at the beginning, variables can be filled with numeric or non-numeric values. The names of non-numeric or string variables must end in a $sign. If string variables are longer than 18 characters, they must be specified with a dim statement, which consists of dim, an asterisk, and the number of characters. Mathematical operations can only be performed on numeric variables. If you need to perform a mathematical operation on a string variable, you can use the internal function val. When the user inputs information, you can save it as individual variables or in a matrix using the mat keyword. Mat can contain numeric or string values, but not both. The mat keyword must always be followed by the name of the matrix. A matrix can contain either string or numeric information, but not both at one time. The name of the matrix determines whether it's for strings or numeric information, and if it's strings, it has a $sign at the end of the name, just like a regular variable. Dim can also be used to set the size of a matrix. For example, dim, and the matrix name will be $, so that it's a string variable, and 5 in parentheses, so this matrix is going to have 5 items of information in it. And each of the 5 items will be able to be as big as 255 characters. To read into a mat using the data statement, we'll start by printing a new page, which is just a great way to begin a reprogram. Then dim our mat, which we'll call names, note the $, and to 20. Then we add the data. We're just going to pick some random names. Notice that the non-numeric information, like the names, are surrounded by quotation marks and separated by commas. 4 will do for now. Then we're going to read into mat names, $, and we're going to put an end of file error handling routine, which will link to the line redimension. Notice that the line label is followed by a colon. We'll redimension our mat names, and we'll use the internal function cnt, which counts the number of items in your matrix, and we'll redimension it to that number. Alright, so save that and go to Tools, Compile BR Program, and let's check it out in BR. Alright, so in BR we'll run our program, which I saved as read pro, and as you can see, nothing shows up. So to test it, we'll do print mat names, and there's our 4 names. Notice that since the mat has been redimensioned to 4, it only shows 4 spots. Great. Notice that I've commented out the irrelevant parts of our previous demonstration. Most of the time, however, you're going to be reading information from a data file into your program. So let me show you how to do that. First, you always have to open your internal data file, and this time we're just going to open it under number 1. Name, I know that my sample data file is called customer.dat, followed by a comma, and it's an internal file, and I'm opening it for input, which means I'm getting information from my data file and inputting it into my program. Now the read statement, read number 1, followed by a comma, and using name form, that's a line label, which I'm going to add in a minute. And we're reading it into mat name $, and the same end of file redimension error handling loop. I'm going to add name form, and I know that in my file layout the names are starting with position 5, and I know that they're 30. Form is a internal function which tells BR the form of the information you're handling at the moment. And notice that since my form is C30, it means it's a character string of 30 places. I'm going to have to redimension my matrices to be 30 characters in each piece. And always remember to close your file using the close statement, number 1, and another colon. Save and compile. So run readpro, and let's see what we have. You can see it's taken the first name from the first record in our file layout. But usually you're going to want to read more than one, so let's take a look again at our program and make some changes. Alright, back in our editor, this is what our program looks like, and let's start to make the changes. To begin with, we're going to redimension our matrix to 1. And then when we start our read loop, we're going to redimension it to 0. And this is since, to begin with, we haven't read anything, so we don't have any information in our matrices yet, and starting at 0 provides a good building block to add pieces of information to. Then our open statement remains the same, but we're going to add a do loop for reading. So do while the internal function file of our file number 1 that we just opened equals 0, which means that the file has been read correctly. I'm going to indent my loop just so it's easier to read. So while the file is read correctly, read number 1 using name form, and we're going to change this to a regular variable we'll call next name $. And we're going to change our end of file to an actual end of file line label. I'm going to keep name form in here. So in the loop so far, BR has read one piece of information, and now we're going to put it into our matrix of names. So mat names $. And we're going to use udim, which is an internal function that returns the total number of items in the matrix. Mat names. And we're going to add one, since we started with 0 here. And so now it's got one item in there. And we're going to put that item so our variable next name is now added to the matrix. And then we're going to loop it until our end of file error routine we'll exit the loop and go to the close number 1. Alright, so to review, what we've done is open the file, and then while the file is reading correctly, we read number 1, which is the piece of information next name, using this form statement. redimensioning our mat names, and then adding next name into our matrix of names, looping until the file is done, in which case we close the file. Also notice that next name needs to be dimensioned into 30. Before saving, I noticed that I need to fix a typo on the close number 1, so we'll go ahead and do that, then save and compile. Run your program, and once again we'll test it by printing mat names, and there you have a lovely list of all the names in my customer data file. Usually you're going to want to know more than just name of your customer, so let me show you how to do 2 different lists. We've already got name, so we're going to add the code, or customer code. So first you're going to add a dim for codes, which will be a matrice, and we'll do the same thing, dimming it for 1, but this time I know that it's going to be 4. And also we're going to, right before our open statement, set it for 0. Then the open statement remains the same. The do statement remains the same. And to the read statement, we're going to add code $. And to the form statement, there was some extra in there, we're going to make sure it says C4 and C30. Since I know from my file layout that the customer code is a 4-character string. Then we're going to duplicate this. To mat codes is what we called it, $, and do the same thing, adding our new piece of information code into our matrix for codes. Let's also add a quick routine that will allow us to see what information we've put into both of the matrices. I'm using a quick for next routine. So we'll say for n equals 1 to the total number of items in our matrices, we're going to print this is just an extra step for convenience. We're going to print the code for each one, followed by the name for each one. So save, compile, and run. In BR, we're going to run read pro. And there you see it prints out each customer code followed by the customer name. Next, I'm going to show you how to read and print just one of these file records. Now let's add some code that will allow the user to choose a customer code and print all the information for that record. Right, so I'm going to simply say print. And for now, we're still just printing directly to the BR command console. In the next tutorial, entitled Handling User Input, I'll show you how to print to the graphical user interface console. So print, in quotations, which record, and then input code num, and then we're going to open and read record. And this time we're going to open, well, we can actually reuse our other one, but we're going to add some changes. Since we closed number 1, we can reopen it with the same file number without causing problems. And here we have the name equals customer.dat, which remains the same. But we're also going to open the key file using keyFname equals customer.key. And that key file was created when I demonstrated the FileIO tutorial. And the key start position is 1, and the key length is 4, since in this case the key we're using is the customer code, which is 4 digits long, or 4 characters long. And this is opened internal input, and we're going to add keyed, since now we're opening it by key. Alright, next I'm going to add the read statement to read it by file. And as you can see, it's read number 1 using rec form. And the key equals code number. And then I'm going to list all 5 items from my data file: code, dollar, next name, dollar, city, dollar, zip, dollar, and phone, dollar. Then I'm going to add my rec form line. And that accounts for the lengths and type of each piece. I'm going to end this read statement with an error handling routine for the no key error in case they type in the incorrect code number. And I'm going to say no key problem, which will put us down to the line label problem. And this will catch, in case they enter an incorrect code, this will catch and route them back up. By printing incorrect customer code, please try again, and then using the line label which rec. And just a note that says ask again. So on an error, the program will be rerouted to ask for the record number again. And notice that when we reroute it because of an error, it's going to actually reopen our file again. And to avoid doing that, we can actually just move this whole section and put it after the open statement. And there we go. Next, I'm going to print it back to the console. So I'm going to print, and then all the pieces of information that we just read, with ampersands to keep everything on the right line, and some spaces appropriately between the zip and the phone number. And then make sure to include your close number 1 colon. And then I'm going to put an end statement there so that it doesn't go through my problem, reprint, try again routine. And let's just look this over real quick. Note that the city variable is also C30. So up at the top, I'm going to have to add something to dim city dollar to 30 characters as well. And once again, save and compile and run. So run our program again. And you can see it asks which record. I'm going to choose 000H. And you can see it prints out the code, custom name, city, zip, and telephone number. And it didn't take the spaces that we inserted earlier because those are used on the graphical user interface console. And that's how you read a record by key. Now that I've shown you how to do it manually, let me quickly review how to read a file and get information to put in your matrix using FileIO. To do this, there are 5 steps which I will walk you through. First, add the library statement to open the FileIO library. Put FileIO in quotation marks, a colon, and then the function we want to use this time is fn open file. FileIO has many other functions that you can use for different purposes, but for today we're just going to use this one. Next, we'll dim the arrays and the forms. FileIO uses matrices a little differently because it stores all of the string data in one matrix and all of the numeric data in another. So here we have customer dollar and customer. So we'll dimension the customer dollar to one place, and in case there's any large strings in our data, we'll use a length of 255 to catch everything. Separate it with a comma and then add customer, dim it to 1, and you never need to add the number of characters for numeric matrices. And then dim our form matrix to one item and a maximum of 255 characters. And the third step is to set the main variable to the open function. And in this case, it looks like this. FileIO will automatically assign a file number when you open a new file. But in order to make that useful to you, you need to name it. And in this case, the customer file in the statement let customer file equal is doing that for us. So instead of using number 1 like we did thus far in these examples, we're going to be using customer file. Let's look at that line in isolation. The let statement, along with the equal sign, assigns value. Customer file, we already said, is the same as the file handle or file number. Then in parentheses, we have the name of the file layout, in quotes, customer, then our mat customer dollar, comma, mat customer, and mat form dollar, which holds the information that we're pulling from the data file in accordance with the guidelines in the file layout. And finally, there's the 1, which is not required, but means that we're opening the file for input, taking information from the data file into our program. And so we're going to read number customer file, and we're going to change it to form of customer file, and that FileIO will pull directly from our file layout. And then it's going to read the mat customer and mat customer numeric matrix. And we'll keep our end of file. Then, since we're using FileIO's form system, we don't need our name form anymore. And the changes we're going to make here, instead of reading our other variable, we're going to be using the FileIO style variable, which will be customer dollar of CU, which is our prefix, underscore name for the name, and we'll do the same thing for code. Notice that since the dollar is in the customer, you don't put the dollar in the CU code. And that's all. And also, we'll have to change our close statement to close number customer file as well. And just to remind you, here's a picture of our file layout. You can see that the name of the data file is customer.dat, cu underscore is our prefix, and under that is the name of the key file and the key code. And you can also see on the left the field names and that's how we pull out the name and code. And on the right is all of the details about whether it's a character or what form it's in, and the field length. And always remember that you have to add the standard FileIO code to the bottom of each program. And that can be found at the very end of the FileIO program. Then save and compile, and we'll run it. Load and run. And so you can see that the program runs, and it looks the same, but behind the scenes FileIO is taking care of the opening the file and reading it for us. With such a small data file, only 5 items, it doesn't make too big of a difference, but once you're dealing with data files with hundreds of items in there, FileIO can really save you a lot of time. Well, thanks for following along, and the next section will continue handling data.